Okay. When I write the ratio of A to B, ratio means the quotient. So the quotient that's what ratio means. So the way you write that, the first one you see is the top one, the second thing that you see is the bottom one, A to B. When I say the ratio of 7, and sometimes instead of the word 2 we do colon, like this, 7 to 11. That means the quotient of 7 over 11. The ratio of 2.3 to 4.5. This will be written as 2.3 over 4.5. The problem is with ratio we like to use whole numbers, not decimals. We got to simplify that. How do we simplify it? How do we make these numbers whole numbers? We can move the decimal point how many places? One place to the right, and this ends up being what? 23 to 45. The ratio of 2 1/3 to 5 1/2. That would be 2 1/3 divided by 5 1/2. Again, we want to use whole numbers, not a fraction. So how can I change this to a whole number? I can take this and change it to improper fraction. 3 times 2, 6 and 1. That's 7 over 3 divided by what? 2 times 5, 10 and 1, 11 over 2. That's still not good. It's not a whole number on the bottom or the top. Well, if you look at that, it reads what? 7 over 3 divided by 11 over 2. That's what it says. Take 7 over 3 divided by 11 over 2. Well, we know we can change division to multiplications. If we do what? Multiply by the reciprocal, which is what? 2 over 11. And when you multiply, what's 2 times 7? 14. What's 3 times 11? 33. So this is 14 to 33. So that's what ratios are. Now, proportion is a little bit different. So let's look at proportion. A proportion is an equation that has two ratios in it. So an equation of two ratios. So for example, I might write 2 over 3 equals 4 over 6. That's an equation. It has a left side, a right side. It has a ratio on this end, a ratio on that end. Well, the question is, how do we solve ratio or proportion. How do we solve those equations? So if you have A over B and you want that to equal C over D, one way of doing it is cross multiply. If you multiply A times D, should equal B times C. Cross multiply. This one times this should equal this one times that. Why is that important? Because soon enough we're going to ask you to solve a proportion. And I'll give you some examples. Let's take the Red Sox. Does anyone know what their record as of today? How many games they won? 49. Out of how many? Win-loss? I think they played more than 81. Let's look at the Red Sox record. We'll Google it. Red Sox. Here is the Red Sox. 49 out of 38. So altogether, how many games they played? So their win-loss, they won how many? 49 out of how many games they played so far? We said they won 49, they lost. What was that number? Where'd you see that number?
It's right below where it says Boston.
Where it says Boston, below it?
Yeah.
Oh, mine doesn't show anything actually under it.
87 games.
87?
Yeah. 38 lost.
Yep. They won 49 games so far out of 87. Well, the entire season has how many games? 162. So if they keep the same pace as this ratio, 49 out of 87, that's their percent win basically. If they keep the same base, the season has 162 games. How many wins we expect the Red Sox to have if they keep that pace? Now, granted, something could happen tomorrow and they go 19-0. That changes everything. Or they could stink and they lose like 15 games in a row. But if they maintain that pace, we can estimate how many games they will have by the end of the season. So that's solving a proportion. Well, how do you solve them? We do cross multiply. We go 49 times 162 should equal 87 times x. (49 times 162), when you multiply these two numbers, it's 7938 equals 87x. To get or to solve for x, we divide both sides by 87. So if you bet on the Red Sox to win like 84, 85 games, you're in good shape. Because right now, if you round it to a whole number, the Red Sox on base to win 91 games. We use proportions all over, not just in sports. I'll give you another example. Your family decide to take a drive from, I don't know, where are we going to go from? New York City to Orlando, Florida. Going to go see Mickey Mouse. The distance from New York City to Orlando, Florida, the highway following the drive there, it's not a straight line, you zigzag around a little bit there. But the distance probably from New York City to Orlando, somewhere around a little bit, probably less than 1,000, maybe a little bit more than 1,000 miles. Let's say that distance is 1,000 72 miles. Gonna use some crazy numbers. I don't want to guess on the answer. So you get in your car in New York City, you put the kids in the back seat, or the trunk is better because you can't hear them that way, and you start driving. You get to Washington, D.C. This is Washington. You want to go visit the White House. I better write D.C. From New York City to Washington, D.C., the distance probably somewhere around 220 miles. So you drove 220 miles so far from New York City to Washington. And let's say it took you 4.3 hours. And your plan to get up in the morning next day and drive all the way from Washington to Orlando. The question is, if you keep that pace of driving, if you maintain that pace you drove to Washington, how many more hours are you going to need to get to Orlando, Florida? As long as we keep up the same pace, we can set up proportion. The ratio, you can put the hours on the top, miles on the bottom, or miles on the top, hours on the bottom. It does not make a difference. Which one you want on the top, hours or miles?
Hours.
Hours, okay. So hours on the top, miles on the bottom. No reason, we could have picked the reverse. So we drove 4.3 hours, and how many miles we covered to Washington? 220. Now, how much time for the rest of the trip? Unknown. What is the distance for the rest of the trip? What is it going to be? Isn't it the 172 minus the 220 that you drove? 1,072 minus 220, 852. That's how many more miles you have left to drive. So if you cross multiply here, it's going to be a long trip. Notice you drove 220 miles in 4+ hours. If you go in 70 miles per hour for 3 hours, how long you drive? At 70. 210. If it took you 4 hours, 220, you go in 105. 55. You go in below 55 miles per hour, that means construction. So let's see what that means. 4.3 times 852 should equal 220 times x. Three, 6, 6, 3.6 equals 220x. To solve for x, you divide by 220. Divided by 220 is going to take you 16.7 more hours, almost 17 hours next day to finish that trip. If that pace stays at that thing, like 52 miles per hour roughly you're going. You're not going that fast. You're probably going 70, but when we say 52, especially if you have kids, Mommy, Daddy, I gotta go to the bathroom. You gotta pull over. They gotta go to the bathroom. You gotta feed them. Let them run around for a while. Get back in the car again. Drive again. 20 minutes later, I need to go to the bathroom again. You know? So that's why the pace looks like 55 miles per hour. We can use it in... So we saw sports, we saw taking a vacation. We can use it in cooking. Cooking. I love to cook. I'm actually a decent cook. My wife and I, we both like to cook. So, let's say I made some prime rib. Everyone likes prime rib, unless you're vegan. But we're making some meat, prime rib. And let's say I'm having a small group coming over. I have 10 people coming to my house. And I went to Costco, somewhere, bought some meat. Atkins Farm, they have really good steak, good prime rib meat. But let's say I went somewhere and I bought, I don't know, 8 pounds of meat, prime rib, to cook for the 10 people. And it was yummy, everyone loved it, it was just the right amount. Now, one of the people there said, Z, I'm getting married. I want you to be my chef for the wedding. I want you to cook prime rib for the wedding, everyone in my wedding. I was like, what are you, crazy? Come on, you can do it. Good friend of mine. Yeah, okay, I'll do it. How big the wedding? Oh, it's a small wedding. Well, it's an Italian wedding. Well, there's no such thing as small Italian wedding. So, okay, how big the wedding? How many people? So I can go buy the meat. Well, I got 200 and so far 64 people coming to the wedding. How many pounds of meat do I need to buy? That's unknown here. If I want to give them the same proportion I gave to this group, so now I can set up proportion. I can put meat on the top, people on the bottom, or people on the top, meat on the bottom. As long as I'm consistent, it won't make any difference. Meat, people, I'll do people on the top, meat on the bottom. For the first group, I had how many people? 10. How many pounds? 8. For the second group, I have how many people? 264. And how many pounds of meat I'm going to need? Unknown. Cross multiply again. What's 8 times 264? 2,102 equals 10x. And to solve for x, you divide it by 10. So approximately, I'm going to need what? 211 pounds. Prime rib. You better take a big car. Throw all that meat in it. Maybe I'll do one more example where proportions are used. Proportions are used in wildlife estimations. Wildlife estimations. Notice the word estimation because nobody knows exactly how many. Take Alaska. How many bald eagles do we have in Alaska? Does anyone know? Nobody. We try to estimate how many bald eagles or how many grizzly bears we have in Alaska. That number is unknown. So the way the government does that, when they want to estimate something, they'll go, okay, we know we can't kill or hunt eagles, but they send these professionals, they go catch some eagles, tag them, and release them. So right now, the number of eagles in Alaska is unknown. But we send these people, they trap them, tag them, and release them. How many they tag? let's pick a number. Let's say they got 10 eagles or 15 eagles. They tag them and release them. 15. Now they wait. They give the eagles about 2-3 weeks to forget about the whole catching them, because most animals, once you catch them, trap them the first time, they're nervous. So you don't want to go back next day and do it again. They might wait a month. Then they go back and catch more eagles and see how many of those are tagged. Now, if nothing major happened, means what? If we didn't have a wildfire in Alaska that killed half of them, or we didn't have some poison go into the water that would change that, really that number shouldn't change. So on the second visit, 2 months, a month later, we go back, and on this day, how many eagles we caught? Let's say we caught 25 of them. Out of the 25, how many were tagged? Let's say 7. Based on that proportion, we can tell you how many, roughly how many eagles are living in Alaska. We do a proportion, and you can set eagles on the top, the tag, the total number. Maybe I'll do total here. So I can do either the tag on the top or the total on the top. It doesn't matter. On the first day, the number of total eagles is unknown to us. I'm trying to figure what that number. How many were tagged? 15. On the second visit, altogether, how many did we catch? 25. And how many were tagged? 7. Can I cross multiply? 7x equals 15 times 25. $375. You divide by 7 to get x. And we estimate about 54 eagles living in Alaska, bald eagles, based on my numbers. That's how the government does that every single time for wildlife estimations. Fish, deer, coyotes, whatever you want it to be. So proportion is really very practical for us. You saw on the STIC website, when you look, there's the bridge I built. But the first day when I met with the students, I said, let's go for a walk. It was a beautiful sunny day. And if you look on campus here, I'll give you the scenario I gave to them. We have these beautiful trees. We have lots of them. And it was a gorgeous, gorgeous sunny day. There's the sun. I gave each one, I broke them down to groups of 2s actually. And I said, okay, each one of you, I assigned them a tree. I said, this group you get this tree, that group you get this tree, this group you get that tree. I want you to tell me how tall is that tree without climbing it. I don't want anyone to climb the tree and getting hurt, because these trees are not small. How tall is the tree? And the only thing they had with them, each one, is a yardstick. You can imagine having something like this with you. A ruler. Take that ruler, 1 foot ruler. Take it with you and tell me how tall is the tree without climbing it. What do you think? Some people start saying, well, look at the shadow. I says, go ahead, look at the shadow. Big deal. There's the shadow. Well, measure the shadow. So go ahead, measure the shadow. It's the shadow of the tree. What's the length of the shadow? You want a number? Let's put, I don't know, 30 feet. You measured it. You got that ruler, you flipped it up and down that. On the ground 30 times. Big deal. How is that going to tell me how tall is the tree? The shadow doesn't tell you anything. At 12 o'clock, there is no shadow. The sun is directly above you. Does that mean there's no tree? At 1 o'clock, the sun just moved a little bit. The shadow might be a foot long. At 2 o'clock might be 4 feet. At 3 o'clock might be 6 feet. At 4 o'clock might be 12 feet. So the tree didn't grow during that time. So how is that going to help me to figure out how tall the tree is? Again, I'm looking for the height of the tree. I'm looking for that distance. I know the shadow is 30 feet. I don't know what the height is. And I go, think. As people walking by, somebody noticed that people also have shadows. So here's Melissa, with the hair there. Melissa is 5.3 feet tall. Melissa has a shadow on the ground. Of 2.7 feet. See where I'm going with that now? As long as you measure the shadow of both them within like minutes from each other. You can't do this at 1 o'clock and at 4 o'clock, oh, you thought about Melissa and its shadow. Well, now the sun moved, everything changes. So it has to be within a minute because we didn't move much. So now we can do a proportion. The height of Melissa, which is 5.3, to Melissa's shadow, which is what? 2.7. It should be the same as the height of the tree to its shadow, which is 30. If we do them within like 4 or 5 minutes from each other, even within an hour from each other, you're not going to be that much off. We don't move much. But usually you want to do them time-wise very close to each other. Now you can go cross multiply. 5.3 times 30 equals 2.7 times h. $159 equals 2.7h. Can I solve for h? Roughly 59 feet. So that particular tree is 59 feet tall, based on my numbers. Without climbing it, without killing anyone. Imagine if somebody climbed to the top and they fall off it now. I'm in jail for negligence probably. So we can use ratios in lots of places. From landscaping to cooking to painting a room, whatever you want to use it. Like imagine if you were painting, you say, well, it took me 3 hours to paint this wall. How many square feet this wall? You calculate the square footage of the whole room, you can figure out how long it takes you to do the entire room. I can tell you, I painted when I was in college. When people call me to give an estimate, I know how fast I can paint. I know how long it took me to do, for example, something the size of this room. I said, let's say, I mean, not this room, this wall. Maybe I can do 600 square feet in 1 hour. So I calculate the square footage of the area I'm painting, and based on that, I know how many hours it's going to take me. And if I want to make $20 an hour, I multiply it by 20, and that's my pay. I go, my labor will be this much money. I don't just walk and I go, that's big house, 2,000. They're going to say, how'd you come up with that number? But if you walk into them, it says, it's going to take me 16 hours to paint this side at $20 an hour, 16 times 20, $320 for this side, $320 for that side, $140 for this side, $140 for that side, add them together, that's how much my labor is. They go, okay, at least he thought about it.